Hi, and welcome to the third tutorial of the pm4py tutorial series. In this tutorial, we will be looking at importing of XES files. My name is Sebastian van Zelst, and I'm a researcher working at the Fraunhofer Institute for Applied Information Technology, as well as the Process and Data Science Chair of RWTH Aachen University. All right, because in general, importing XCS files in pm4py is very straightforward, in this tutorial, I will be spending actually quite some time talking about XES, so the file format itself. And finally, I'll show a script on how to import XES. So it's not intended to be an exhaustive definition of the XES standard, because there's a lot of information on the web and also very easy to find, actually. However, nonetheless, I would like to sketch a bit of a basics of XES, so that people that would like to start with process mining and see such a file understand what they mean. All right. So to again sketch a little bit of context, what for most people should be very clear right now. So what do we do in process mining? We analyze processes that are executed. During the execution of these processes, for example, logistics, financial domain, healthcare, or the online shopping domain, there's all kinds of information generated and stored in the information systems of the different companies that execute those processes, as I have already explained in our previous tutorials and demos. So if you're not aware of those ideas, then please take a look at these different demos and tutorials. So in the end, we have a lot of operational event data that is stored in the information system of a company in a database. And in the end, the goal is to get insights of our process by means of analyzing that event data. That should all be very clear. And as I've shown you in the previous tutorial, the most simple form in which we can look at event data is simply the table that we also see in this slide right here, where we have a column that represents, for example, the ID of a specific order. But basically, this first column that we often refer to as the case identifier or the trace identifier or the process instance identifier allows us to identify what happened in the context of a specific instance of a process at what point in time. Second column allows us to see what happened, so that's the activity column. And finally, we have the timestamp column. Again, this should all be very clear. And in our previous tutorial, we saw basically that CSV files are a way to store this type of tabular data in a file, in a flat file, where either a comma or a semicolon is used to separate the columns in the data. And in the previous tutorial, we've been using a process and data that was generated by means of generating some event data out of a process that was looking like this, where I will briefly again describe this process. So we'll be using this as sort of a running example throughout this tutorial series, where we first have always an activity that refers to registration of a request, after which there is a concurrent branch. On the one hand, a ticket check is being performed, and on the other hand, there's a choice between a thorough or a casual examination of the ticket, for which actually, in this case, a compensation request is being handled. And then there's a decision. And after the decision, the decide activity in this diagram, we either pay the compensation, reject the request, or we reinitiate the request, which means that we again have to do the examination and the ticket check. So I have more elaborately described this process model and also the process in general that it models in more detail in the second tutorial. And I would again refer to that. Maybe in the future, we will also release a specific tutorial on modeling processes where we discuss a variety of different modeling formalisms. Anyway, we're again using this example in the data that we're using. Now, as I said last tutorial, in tutorial number 2, where we looked at importing event data, we were looking at the data in this format as we see in this slide. So we actually have the first row defines the columns that we have in this table. So we have case information, We have activity information, timestamp information, etc. And then the second row in this example actually shows us the first event, the third row, the second event, etc. And this is nice. However, there is a problem when we are using this data format and we have what we know as case or trace or process instance level attributes. Now, what does that mean? Consider, for example, that in the example data that we also show here, there is a sort of for each event, so for each row, before the resource, there's a number. Like, for example, if you take a look at row number 5, we see that before the name Sarah, there is a value 200. And that value that refers to the costs of that specific event. So executing the decision activity, for example. So the 5th row of this file, we see that the decision activity is performed at January 6, 2011. And that has a cost of 200. Now, a problem arises when we, for example, have certain costs that hold for the process in general and that are stable, will not change, are static for the process in general. Because how should we represent that? For example, what we can do is whenever we have the first event of a specific trace, we write a value that represents these costs. And then all the other rows for the same case will have no value. That's an option, but alternatively, we can just basically repeat the value, the costs of the whole trace. If we only know the cost for the whole trace, we can repeat that for every single event that we record. Right, so the point I'm trying to make, and I'll show you a bit more examples in the next slide, is that there are sometimes when we execute a process, there are certain variables, certain features of that process that we would like to record in the data that will not change over the course of the process. And when we then want to record that information in this sort of flat CSV representation, we run into the issue that we have to make a design decision. Either we replicate that data for each in each event, or we just position that trace level data in one unique event of the trace, like the first, and then we always have a null value for all other rows, for all that column in all other rows. So as I said, a few other examples you could think of. For example, if we take the medical domain, the patient age will of course change every year, but if we record the birth date of a patient, then that is stable and it will not change throughout its medical process. And obviously what we don't want to do is in every single event, in every single medical activity that we record in our database, we don't want to list the patient's birth date. Similarly, the gender at birth, even though, of course, in a variety of countries, it's now possible to sort of formally change your gender, but the gender that you have at birth is something that remains stable forever. Also, chronic diseases are very likely not to change. It's not impossible, but in general, when you'll be having a medical treatment, it's not so likely that a chronic disease that you might have that might also influence the medical treatment that you receive changes. So again, these are examples of parameters of data attributes that we can record in the context of the execution of a process. In this example, I took some medical example, but in general, that will not change during the execution of the process. Another example from logistics is that in general, when you finish your order at the web shop, and when you've done that, then the logistics process starts, and it very irregularly happens that actually the delivery address is changed. These days you can actually change it online, but assume that we're not able to do that, then again, this delivery address is something that will not change in the logistic process. So when we store event data in a CSV format, storing these case level attributes is quite inconvenient, because you either have to replicate them or you have to find a mechanism to sort of say, I'm only storing this type of information in the first event that I see for this patient, and then I assume that in all other events, that value actually remains the same. And this is actually where XES comes in, because XES is an XML-based file format that allows you to basically replicate such information only once. For those that are a bit have some knowledge of XML, in the end, XML is basically again is a file format that allows us to store data in a tree-like structure, like a mathematical tree, in a flat file format. And what's nice about XES is that it's actually a standard that is approved by IEEE for event log data. So it's a standard. It's completely clear if XES file follows the standard that is also accessible through the website that I'm listing here on this specific slide. Then every process mining tool, and whether you use pm4py or Prom or Solonis or Disco or any other commercial tool for that matter, I would like to stress that I do not have any preference for any commercial tool, nor any open source tool, except of course I'm very enthusiastic about pm4py. But in principle, the idea of this is that all these tools would then give you the same results when you load the specific file in this XES format into them. To give you an overview, on the website you can also find a list of tools that support the XES standard. So here you see a snapshot of the current support of tools that support the XES standard in one way or the other. There's different levels of support that can be defined. So certain tools or libraries support more functionality of Xcs than others, but in principle, these tools have a certification that they actually support XES. And as you can see, pm4py already supports Xcs since its version 0.1, and actually has been supporting it ever since in the highest possible level achievable. Anyway, so XES, how does it look? So for those that are familiar with XML-based files, for example, if you look at HTML, it's basically any web page contains usually a bunch of HTML statements. Then you know that XML-based files consist of a tag that opens a concept and a tag that closes a concept. And in XES, these concepts are very close to what we all know now. We should know the concepts that are relevant in process mining. So in XES, you can define an event log by basically writing a log statement. Here on top of this slide, you can see that written down. So if you see a statement that looks like this, and I'll show, of course, running example file in a minute, then you know, okay, a log is defined. So and actually XES file, even though this is almost never applied, can theoretically speaking contain multiple of these statements, and then it just describes a multitude of event logs. This is theoretically possible. As far as I know, the standard allows for this, and if I'm wrong, then please correct me in the comment section of this video. Then this log can contain an arbitrary number of traces, like we've seen. So these traces are basically representing, okay, which events have been executed in the context of this process. And then finally, each of those traces can then again contain a bunch of events, which again you can close and open by using these tags. And actually all these different concepts, so logs, traces, and events, can also have various attributes, various data attributes that describe certain phenomena in the process. So I guess now I will show you an example of an XES file using the running example. And I will briefly go through it and explain what we see. So actually what I did is I have now created a beautiful XES file that represents the exact same data as the CSV file that we have used in the previous tutorial. It's the CSV data that corresponds, the process data that corresponds to the example process that I've showed you in this tutorial as well, this registration request. And what do we see here? So the first line, we see that this is an XML file. Let's skip that. And then the second line, we see that a log is defined, and the XES standard version is 1849-2016, which is actually the current standard. The next line is basically line number 3 is basically a data attribute of this log, and the key of that attribute is the origin, and the value is the CSV. And that actually shows you that I have converted, in this case, actually using pm4py, I have converted the CSV file that I used in the previous tutorial into an open access standard file using pm4py. And in the next tutorial, I will show you how to do that, because then we'll be looking at how to work with event data in more detail. So however, so if you would ever ask the origin property of the log, you would get that it is a string with value CSV. Then there's a bunch of extensions in line 4 until 7, and I will explain the concept of extensions in let's say 5 minutes from now. So I will get back to that later. Let's start to look now at line 8. So in what we see in line 8 is a trace clause, or let's say it starts a trace concept. So, and I'm using Notebook++ here, so I can actually, and that recognizes XML, so I can press this minus button here, and then it closes that specific trace, right? So I see that the first trace in the end spans line 8 until 45, because in line 46, the next trace is there. So I will also close that, close all these traces in this log file. And then you see, okay, this log file in the end contains 1, 2, 3, 4, 5, 6 6 traces. And if you recall the previous tutorial, you might actually remember that the event data, the CSV file that I was using, also contained 6 traces, because these were actually exactly the same traces as we have in this specific tutorial. Now, if I open up the first trace, which is again is nice, is a nice Notepad++ feature that it recognizes XML, I can do actually the exact same trick with the events that are part of this trace. So let me do that. So I will close the first event, the second event, the third event, the fourth event, fifth event of that specific trace. So what do we see? The trace has, apart from the events, it also has a child tag of type string. So this is an attribute specified by the XS standard that you can give a trace or a log these type of children as well. So next to the event child that a trace can have, you can give it a string child or an integer child, etc. Again, I will not go into extreme detail. Please visit the website that I also referred to in the slides. But what we see is that this trace has a string value child with a key concept name and a value 1. And that actually refers to the name of the request ID. So if you recall the previous table that we had, that was the first column actually showed you, okay, for which instance of the process has this specific bunch of process behavior been executed. And that's actually what this key is concept column name represents. So this trace can be identified by its unique value 1. Although uniqueness is not necessarily defined for this attribute, that's something that we as a user have to specify on top. So if I open up the second trace and I do the same trick, so I'm opening the second trace and then I'm closing all the events to give you a bit of an overview, what we actually see is that that trace has a string with a key concept column name and a value 2. And if I do the third one, I again have a string with the concept name with the value 3. And then I guess you can sort of understand that if I would now open up the fourth trace, that we would again see, and you can see that here in line 151, that the first child node that this specific trace node in this XML tree has is a string with concept value 4, and then this guy has 5, and this guy has 6. Why is this so ordered? This is because actually in pm4py there is an automatic sorting that takes a potential lexicographical sorting on the identifier of a trace. That's why. All right, so we've looked at traces now, and we've seen that we can add an attribute to that trace. Let's take a look at the events. So what I see here is if I open up the first event in this specific data, is I see a bunch of child attributes for this event. I have a string typed attribute, child attribute, that has a key, again, concept column name, and it has a value register request. And without going into too much detail of this concept column name key, I guess you can all see that, of course, this specific string attribute, this child string, refers to what activity has been performed in the context of this trace with, identifier 1, which is a register request. Then I see a date object with a key time colon timestamp. And I see, in this case, in a string basis, I see a nice date time format, timestamp. And then I see an integer, which has cost total and a value of 50. Again, property of the event, I see an or colon resource with value Pete, and I see some integer with the key at index value 14. Now, these first 4 children, this register request, this date, this costs, this resource, should be very familiar because we have exactly that data in our CSV file as well that we used in the second tutorial. So again, this shows you that the register request activity has been performed at 13th of December 2010 for instance of the process identified by value 1. Pete executed, cost was 50. Then if we take a look at the second event of this trace, we see that the thorough examination was performed by Sue, cost 400. Third was a check ticket by Mike, cost 100. Fourth was decision by Sarah, cost 200. And finally, a reject request by Pete. So we see that for the process instance of this trace with identifier 1, we see a rejection was performed. So I hope that you notice that in this specific example, the events are already ordered based on their timestamp, but this is not necessarily the case. So like in a CSV file where I can basically arbitrarily shuffle the events, the rows, I can do the same here. I can, if I want, I can take this second event and put it in front of the first event. This is fine. This doesn't at all jeopardize the validity of this event log file. However, what I should do is when I import it, I should then somehow, again, for each trace, sort all the different events that are there on their timestamp to make sure that everything is in line. But in principle, XML and thus XES does not specify in this context order on these events is not specified, right? So final remark that I would like to stress about this file at this point in time is that this index is an attribute that was generated by pm4py And if you have a very good memory, or if you have actually been watching the second tutorial just now, you remember that what we did in pm4py is we did some sort of transformation on the data frame that we imported, to set some basic properties. And what that transformation also does is it records the original index of the event in the provided data table. So that's what it's doing. So actually from this, you can see that in that data table, this event was actually row 15 of that data table. And this event, which is actually the first event of trace 1, right? Because I have kind of copied, I just swapped them, so I'll swap them back now for the sake of the example. But this was the 14th. Then this event in the original data was actually registered at row number 16. So this is kind of the row number that is there of the original data. And if you have a very good memory, or even a photographic memory, you remember that in that CSV file, the first case that is listed, I think, is case number 3. That's my hypothesis. I have no photographic memory, so I don't remember for sure. So this is a sort of an experiment in this tutorial. But as you probably have remembered from this tutorial, is that the traces in this file were ordered 1, 2, 3, 4, 5, 6. And as I remember correctly, the first trace in the CSV file that I used to generate this specific XES file was with case ID 3. So if I open up this third one and I open up the first event, that should have the index value 0, which is like the first, so row 0 of your data row that you used. All right, so that's about XCS. So I hope that I've shed a bit of light on XCS. For now, using the running example, let's go back to my presentation because I would like to share a few more things about XCS before we go into handling them in pm4py. Because the first few rows in the previous table that I've shown you were actually referring to extensions. And I think the name of extension is chosen a bit wrongly, because these extension access actually describe contextual meaning of attributes for some omnipresent concept. And I like a good example is what is known as the costs extension, because costs of either traces or events are quite clear. It's the costs associated with execution. And the idea in XES is that in the file, you can specify whether or not you are using a certain extension. So if you specify that you're using the cost extension, then it means that whenever you observe in the file cost followed by a colon, that after that colon, there is a key that is well defined. So for example, cost colon total, which is an attribute that a child attribute that you can put under a trace or an event, describes the total costs of that trace or event. And if you write cost colon currency, then you are actually describing the currency of that specific cost that you have listed. So if I go back to my previous screen, so having our running example file, you see that there is a total of 1, 2, 3, 4 extensions that are active in this specific file. And you also see the prefix that you have to observe. So the word you have to observe prior to a colon to know, this sort of child attribute actually refers to that contextual meaning. And actually, there's 3 out of these 4 have a very natural logical meaning. So this organizational extension refers to properties related to the organizational dimension of the process. So think of resources or employee groups. Then we have the cost extension, which I've just sort of explained in the previous slide that I've shown you. And then we have the time extension, which obviously refers to time. So for example, if we drill down in this first event, let's go back to the first trace. in the first event of the trace, we see that the row 12 says there is a time-based property. And more specifically, so we see that because of this time colon, more specifically, we have a timestamp. And this describes, okay, so the value that you get from this date object should be interpreted as the timestamp of this specific event. So why is this useful? For example, if you not only have the time at which something happened, but you also have the time at which you have planned something to do, you can still put another date object in this event, but you use a different key that is, for example, only known for you as being the time that you plan to do this activity. And then from that, you can derive whether or not you were before or after the planned time of the execution. So similarly, in this example, we see this in row 13, we see this cost colon. So that tells us this is something related to costs. And in total, I see that the cost of this event were 50. I cannot see it with currency because it has not been recorded in this specific example. But if, for example, there would be cost colon currency and then the value would be euro, I would know that it would be 50 euros. And if it would be dollar, it would be $50. And then finally, of course, so you could even, do all kinds of fancy stuff by saying at that point in time that had this costs. So at that point in time that had an equivalent cost in yen of this amount. If you then backward use, exchange rates backwards. Then finally, this org colon, as I said, represents organizational information. And in this case, we have a resource. So we know this is whatever this string represents is actually a resource named Pete. So as you can see, there's this more generic extension. It's called the concept extension. And in almost any XES file, you actually see that concept extension there, because the concept extension allows you, for example, to give a name to an object. Like we want to give this trace a value name, a name that represents this trace, and that's what the concept extension does. So again, note that a concept name, there's no uniqueness assumed on this, right? So technically speaking, you can make another trace object that has the same name as this trace, right? If you import it, it will observe that, okay, this is a different instance, it's a different trace, but it has the same name. So it's a bit, even though we use this quite often to identify traces, technically speaking, that's a bit dangerous, but we almost always do this in our process mining community. Then, for example, here again, so an event can also have a name, and usually this refers to the activity name. And here, the fact that something is not necessarily unique is actually brilliant, because it allows us to register that multiple activities that have the same meaning or same name have been executed, right? So if I take a longer trace in this event data set, and I have to find one that is significantly longer with a repeated execution. Wait a second, I think. This is an example. You see that this trace, which has name 5, actually has examine, casualty, check ticket, decide, and then reinitiate. So this event later again describes the check ticket activity. So that's why there is also no assumption of uniqueness on using on this attribute. All right, so final thing about this is that you can see URI specified here, URI specified for every extension, and that actually gives you the description of that extension. And that's actually also quite interesting to show you that specific thing. So here I'm showing you the XES website. This is like the homepage of XES standards. So as I said, if you want to know more about specifically the whole standard, there should also be a PDF file here that actually describes it. It's this preprint of the published standard, so that really describes it in depth. And also describes like a UML classifier classification diagram, UML class diagram of the standard. However, these extensions that I'm talking about are also listed here. So some standard extensions, again, the cost extension, if I open that in my browser, I see the definition of this extension. So actually this is very familiar because this is also listed in the header of the XES file that I've shown you. And here you see actually in command, in XML command, you know, what it represents. And then, for example, you see for the cost extension, so if you use cost and then a colon, you can on a trace level specify a total. That's one, and it should be a float. Actually, we used an integer, so don't tell to anyone that we use an integer there. It should be a float. And then a concurrency. So cost colon total can be specified, and then from this document you can, if you want to know the explicit definition, what does it mean, you can find it. You can even find aliases of that. You know, you can find the more descriptive name here. This is alias in different languages in some cases, and you can specify a currency. And if you want, you can specify a list of objects that actually drive the costs. So it's quite extensive. And interestingly, if I close the trace definition for events, you can define the same things, right? So you can define it like on an event level and on a trace level. All right. So another one which is very often used is the concept extension. And as you can see, you can give the concept extension, you can give that to the log level, the trace level, and the event level. And at the log level, we can basically give a name to the log using the concept prefix. So concept colon name gives a name, stores a generally understood name for the log, as you see here. In the trace, we can also only give it a name. So concept colon name stores a generally understood name for the trace. Usually the case ID. Usually. As I already indicated, this is a dangerous statement because it is not necessarily unique. There's no global uniqueness assumed on this. Event, same idea. In the event, you can specify, in general, a name, but you can also specify an instance. So in some cases, in the example that I gave you, if you have repeated executions, you can basically say, okay, this event with this specific name, check ticket, belongs to this instance with ID 500,000, and this other check ticket activity actually refers to a different instance of the activity. So as is also described here, this allows us to differentiate multiple instances of the same activity. There's all kinds of other interesting extensions, like the time extension, which basically is only defined, as you can see here, for events. So you can only use the time extension for event level to specify timestamp. And this is really only for the occurrence, right? So you can, of course, put more dates in your data, but you can only use it for the occurrence. And then finally, I think a very useful one as well to know about is the lifecycle extension that allows you to specify, for example, whether an event refers to starting, completing an event, so an activity. So some cases you have start and end times of an activity, then you actually split that up into different events. So one event with an activity name, register request, for example, and a lifecycle transition value of start. If you use a lifecycle model that supports that, I will not go into detail there. It's really too advanced for this tutorial. And you have another event that has, again, the register request, concept name, and then, for example, has a lifecycle transition complete. So you know that the first event refers to starting that activity and the second event refers to ending that activity. Then again, if you have additionally this instance identifier from the concept extension, you can even, in repeated executions, you can still keep them apart. All right, so that was about XS. So as I said, the goal, even though this might look like a very extensive explanation of XS, I think I just scratched the surface, and there's much more interesting stuff there, and specifically the class diagram is very helpful to understand it. So before I go into importing it, I would like to say that there's a lot of real data sets that have been made available to the public that you can find on data.4tu.nl. This is not the most internationally, usable name, but it works, right? There's a lot of data, and you can either search there for process mining or BPI challenge. So I'll quickly show you how to do that. There we go. So I have opened it here, and let me go first to data.4tu.nl. So this is the website. So if you go there and you see something like this, you're in the right place. If you search for process mining, this is basically a large container of all kinds of research data and is maintained by four Dutch universities. That's why it's called 4TU. Technical universities. If you search for process mining, you get an insane amount of objects in this collection. All kinds of stuff. And here's some data sets. Actually, there's a lot of data there. Like, is experimental data for software data and analytics by a former colleague of mine, Song Liu. And as you can see, as I said, these are data objects. So these can be any type of file. So this is probably a zip file corresponding to his PhD thesis information. His PhD thesis. Then there's a data set, for example, this data set called BPI Challenge 2019. You can't preview this file, as you can see, but you can still download it. And here it is, BPI Challenge 2019.xs. Now, why did I also mention that you can search for BPI Challenge? That is because every year in our scientific community, we do sort of a process mining contest known as the BPI Challenge, where the goal is that you deliver a report based on a data set that answers certain questions about that data set that the owner of the data set has. And for the purpose of this challenge, every year, the second promoter of my own PhD, Boudewijn van Dongen, spends a great amount of time, which we should all appreciate a lot, on obtaining these data sets. And they are always shared with the public. So if you search for BPI challenge, you get event logs that are coming from real executions at typically anonymous companies, and they are anonymized. And here you see that there's a lot of data sets like BPI Challenge 2018, 2017. There's also often a description of the data set available, so you actually get some contextual information. It's extremely nice. Sometimes there's certain collections. So sometimes a challenge actually consists of 10 different data sets, and then you can download all of these data sets. And here you can, for example, see that if you then scroll down within this collection, I'm now looking at the challenge of 2016. You see a bunch of, XES files posted by Boudewijn van Dongen. So, for example, in some cases, these are not even XES files. Sometimes they are CSV files. Now, what I did is I downloaded one file of the BPI challenge of 2015 that I would like to show you. The BPI challenge of 2015 is a very nice challenge, because it actually has 5 different data sets of 5 different municipalities that aim to execute the same process. And I think, actually, scientifically speaking, there's a lot of questions about process comparison and comparison of logged data that can still be actually answered using this data set. But I wanted to show you a bit of a XES file that you can download there, free of charge, public domain. You can do with it what you want. You can do it use for research, for prototyping, whatever you want. How does it look? So again, now if you go through this file, you now already know the extensions. You know what they mean. Great. Then there's another concept that I haven't touched upon, but I will briefly explain it. There's globals. Globals are actually also, again, it's type of a name that I find a bit confusing with what it actually means, because a global is actually a default value for a certain attribute. Why? Because globals are guaranteed to be there. And if they're not there, you have to use the you have to basically use the value provided. For example, global scope trace means there are some attributes that you can always find in a trace, namely a start date, case status, request, complete, concept colon name, again, extension, last phase, case type. So this is always there. And if it's not there, the parser of your XES file should then automatically take these default values and put them there, so that when you're programming, when you're using this file, you are guaranteed that this attribute is there. Then another thing, again, a global on the event level. So now you know what globals mean. Then another thing, that's the final thing that I haven't touched upon, which is really nice, is the activity classifier. This allows you to identify how can I recognize, or how should I look at activity instances. And a classifier, for example, tells you that you can look at an event, and then you have to take the concept colon name and the lifecycle colon transition, and that together should be seen as something that happened. So in this example, it might be the case that you have start and complete of activities, and that's why you have to take a look at the combination to figure out what the event means. Then there's also a classifier that says if you take the attribute called activity name NL, you actually get the Dutch version. If you get activity name EN, you get the English version. And then finally, it also says you can also take a look at the resource value, the org colon resource value. So you can take that value, you can take that attribute, and then and that represents actually the resource. So it's a mapping of that, well-defined extension-based thing to, how to classify, how to look at these events. Maybe a bit cryptic, but still. What is very important is that, of course, if we specify, look, you can identify events by taking the concept name value of the event and then appending the lifecycle transition value, that they should be omnipresent. So this should only, so when we then look at the globals of these events, so when we look at this part, we have to simply have the org resource, concept name, activity name NL, activity name EN, and this lifecycle colon transition. We have to have them in the data, in order to be able to define these classifiers. And then there's a bunch of meta information, like already here you can also ingest meta information. Again, this is using an extension because you can see this colon structure. So this is the meta org extension. For example, here you can already put statistics of the log in this meta object here, so that people actually don't need to traverse the whole log to get this information. Right, so you can, of course, then specify that. So I'm basically, as I said, so this is a lot of meta information. Again, here's a lot of meta information. So also, again, it's like how many times is this specific activity classifier combination seen, blah, 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 blah. So I'm trying to basically close a lot of these these meta information of this log. So again, the Xcs standard allows you to specify all this type of information, although these extensions are, of course, not part of the standard. They are extensions. That's why they are called extensions, obviously. So let me just search for the first occurrence of trace. So actually, the first occurrence of trace in this specific data set is only at line 11,834. And again, that has a lot of information available. Some of them should be globally omnipresent. And then here you see the first event for that specific trace. So that was actually all I wanted to tell you about the OpenXES standard, which I think is greatly helpful. Again, it's not at all, it's just scratching the surface of certain concepts, but I think it helps. I will show you how to import XES file. And what I would like you to take away is that if you import XES file, then basically you get an event log object back that we defined in pm4py that mimics a list of traces, and traces themselves are lists. So it's a list of lists. It mimics a Python list. And that means that you can do anything with it what you can also do with a list, but it contains trace objects, obviously. However, if you do that, it's a bit dangerous, because then for example, if you would like to use lambda functions and you would like to apply a map on top of an event log, you can just do that. However, the result is this lazy evaluated map object that is no longer an event log. So in the next tutorial, I'll show you a bit more about how to do that, because I've built some helper functions in pm4py to accommodate for this issue. However, today we will just focus on importing event logs. And as I said, it's so simple that I can just basically tell you this in 1 or 2 minutes. I'm in my, oops, I cannot see my screen. There we go. Let me just. So I have an example script here, which is called importing XES file example py. What does this file do? It imports pandas, but we don't need pandas, so I'm just removing that. What does it do? It takes a XES log that is actually listed in the folder above the folder that I'm using in this example. So I'll just show you in a minute. But what is it doing with the log? You give it the file path, this function, and then it reads the XES file with the pm4py.read XES. And that's all you need to do. And then you're reading the file. And then the remainder, what we're doing, and to sketch also a bit of the nice functionality of pm4py that you can put in arbitrary data objects, is that we again, like in the previous tutorial, we query the start and end activities and how many times they occur. And we can use exactly the same code for this. So if you previously wrote a script that does this on a data frame, you can just import the event log. And even though it's a completely different object, pm4py will then actually convert it for you if it's not in the right format, because it does a type check. So it checks, is this a data frame or is this an event log object that we define, etc. Right, so what we're doing in line 5, we just read the file, we get the start activities, we get the end activities. I'm going to save this and I'm going to show you. So if I go one level up in my folder structure, I have 2 files there and 2 folders, and 3 folders actually. So a virtual environment for my Python distribution. I have the running example CSV that I used in my previous tutorial, and I have a running example XES. And if I open that, you see that it's remarkably similar to the XES file that I've shown you to explain a bit what happens. It's actually the same file. All right, so if I now go back to my folder for the 3rd tutorial, again, there's one Python file that is going to take the XES file in the folder above and is going to import it, and it's going to fetch the start and end activities. There we go. You see, for example, that pm4py shows you how many traces are in the log, and then shows you a progress bar. This is a contribution made by someone outside of our own group. So this is also only part of the public release of pm4py. We also have a private release, and of course we don't integrate any public contributions to our private repository. So this is only part of the public GPL-based release of pm4py. And it shows you a bit of information, because for larger files, this can take a while. So then you have some information on the status. And again, we see, like in the previous tutorial, that there were in total 6 register request activities that started this process, and there were 3 rejects and 3 pay compensations. And that's it. So that's basically all you need to do to import a log. And that was basically the tutorial today. So a large part of the tutorial was spent in giving you some insights on the XCS format, which is, of course, I think very helpful. And in the next tutorial, I'll go a bit more into details regarding, working with event data. So I will also spend some time in showing you how to, for example, apply a map or a filter function on a log object to retain certain traces. So thank you for watching, and I hope to see you in our next tutorial. Take care.